when two waves meet each other, they interact. If we take the simple example of a string, wave on a string, say we have a string and there's this wave heading to the right, and then somebody's flicked this end of the string, and then somebody else has flicked this end of the string, so we have this wave, and they're heading toward each other. When they meet, they add. Both of these are going in the same direction, so this would then, when they meet, they would create a wave of larger magnitude. And then afterward, these waves would just kind of pass through each other as though nothing had happened, which is kind of weird to me, that they would just cross over each other and then not change on the other side, but that's how it is. Likewise, if they are in opposite directions, and say pretend these are the same size and shape, then when they meet each other, they would cancel out completely, but then kind of reappear on the other side, continuing on. Now, on the surface, this might seem to violate conservation of energy. There's some amount of displacement here and here, and then it just goes flat. Like, where did that go? Well, at this point, it actually turns out that when it's flat, the speed of the wave traveling down the string is the fastest. So the energy is still there in the form of kinetic energy instead of as kinetic energy, as the potential energy of the string being displaced from its original position. So if we have two sources of waves, they'll generate what's called an interference pattern. And the next video is not one I made. It's one that I found on YouTube that it's really old, but it gives a good explanation of interference and how it works, dealing with water waves. And in the video, there's some interlocking circles. And they're created by light shining through this tank of water. And the bright areas are wave crests and troughs. And the dark areas are no wave. So where destructive interference occurs, it's dark. Where constructive interference occurs, it's bright. It's not necessarily easy to see that from the video, but for the rest of it, it does a good job of explaining interference patterns.